Okay, I'm so sorry that what happens tonight, but it was okay about 15 or 20 minutes ago, and suddenly I cannot log into my Blackboard account, and it says whatever the certification is expired today, right? So I don't think I can log in. I can log in tonight, so I'm gonna check this stuff tomorrow. But there is something I want to talk about tonight. So please just watch this video and please consider that when you do your project. Actually I want to talk about that on last week, but somehow I just forget to mention that. So it's like this. We talk about like whenever we want to measure some length or the positions of a point, if our students are playing around it, sometimes it's very difficult to let the GeoGebra knows that we got the same 2 points on the same points or something like that, right? So you know what we are talking about. So my suggestion was set this magnetic to fixed grid only. In that way, the points or the points actually are just only landing on the grid points only, right? So we can just restrict some freedom of choice of the position of points, right? And then there are only certain types of length or shapes are possible for our students. So uh, we can guide them that let them make certain shapes, right? The problem for this one is if you just use this style, then when our students are playing around it looks like it's just jumping around, right? Not smoothly kind of moving, right? So it looks like we only accepting integer values or something like that, right? But it should be free points, right? Free positions like that. So, uh, okay, it's one of the suggestion is like this. I think I mentioned this one before, but not for this purpose. So it's like this. Uh, right now, the problem is the unit size is too big, right? So it looks like our points are jumping around. So you can just kind of zooming out, make our grid point size is kind of small enough, but when you just zooming out only, then automatically GeoGebra changed the unit length, right? Like one to two and two to five, like that, right? So it's not what you want. Actually, you want this the grid points, right? Can you see that? So just we want to keep one as our grid size. So our points are landing on this grid points on there, right? So uh, the way you can do is go to the graphics, and for x-axis the distance means the fixed unit size, right? So no matter what, one is my grid, right? So now you can see, right, these points landing on those size 1 grid, right, for x-axis, right? So do the same thing for y, check mark over here and hit 1, hit enter. Now you get all this, right? Then now if you just zooming in and zooming out, doesn't matter, our unit size is 1, right? And no matter what the real length we get, right, in this view window, right? So if you're really zooming it out far away, then our points looks like slightly smoothly, right? Right. So if you go further, then it looks like almost our points looks like smoothly moving around, right? But they're actually landing on certain grid points only, right? So like that. And after that, height, axis, and grid lines, then can you see that? It looks like kind of smoothly moving, right? So in that way, now whenever you got a certain cases, it's easier for our students, right, to find those kind of cases, right? So everything depends on how you want to make the plan, right, for your teaching model. But this is one technique that you need. Okay, I think if whenever you need it. Another one today is the project conjecture. I said it's okay because it's conjecture, so you can just make the diagram and put the questions. That's the minimum requirements. And I wish you could have time. You can find some time, so put some more steps. But uh, starting from next conjecture, the next project, which is triangle, right? Remember this. Why you want to make this? This is kind of hands-on activity for our students and let them find the theorem that we want to talk about, right? So it's not just enough to make certain shape, right? And just toss out the answer for them, right? Like a theorem is like that, right? So no, we have to really guide them. So, I don't have that, my Blackboard account. I cannot log in there, so I cannot see that. But what I remember is project triangle number 3 or 5, I think, right? I think it's 5. I don't remember well, but please look at that. So it says like having a line, so AB, and another line is parallel to this line. So for that, we need a point, right? In list, and use this one. We can make it. Oops. This one and that line. Okay, so now then it says choose a free point on this line, right? And make it C. So now this is kind of common mistake. If you choose this C, why not? It's already C. So it says after that make a triangle ABC. Okay. So if you do this one, then the task was like measuring the inner angles and the area of this one. So area is automatically appears over here. Angle you have to just make it. Okay, so it's not a problem. Okay, so far. Now the problem is what we are looking for from this task, from this project. Through this hands-on activity, and actually suggests to change dragging this point C along this line, right? And to see what's changing in the angles and actually angle sum, right? But the angles and the area of this triangle. Now, if you make this way, then when students are moving around, they got all different areas, right? Because you cannot keep the same distance between these two parallel lines. So that's the key point, right? That's what it says. Make AB, line AB, and construct a line which is parallel to AB and choose free point on that line, right? So we shouldn't use a DC, right? DC is only for just kind of make the distance between these two parallel lines, right? So if you do this way, then you really kind of did totally different ones, right? Not the goal of the project, right? So you're going to lose big points if you do this way, right? So for this one, you have to choose another point, and your triangle must be AB, this one, right? So if you already did this way, then you can change it, right? Just select anyone and change the name, right? Okay. But before doing that, let's make triangle looks like ABD, right? So go to triangle, then the command is ABC, right? But you just simply change ABD. No, I have to hit enter first. So ABD, hit enter. Can you see that? It's changed like that, right? Let me bring it out. here. Okay, let me go over there. Now, another thing is when we define this angle, we use BAC, right? So it's just keeping that way. So click that angle and angle BAC, then change that one to D. Okay, now then, whenever we move this one, it's good. But in that project, it's asking construct C, right? The free point C on that line. So we want to make that one as C. All you need is change that one to C. Then the previous original C is automatically changed to another name, right? The label is changed, right? Like a C1. Okay, so you can just let it go, right? We don't need to change it. Even we don't want to use this one, right? I mean, we don't want to see the label of it. So like that. Then my suggestion is, yes, you have to let your students know which point is for what purpose and like that, right? So if you really don't want to change the distance, then you can hide this one, right? Don't show it, right? Then your line is just fixed like that, okay? The only thing is just changing AB, then you can see that way. And in this way, when you're moving around this point C on that line, your students could see the area of this triangle is never changing like that, right? And if they cannot believe it, my suggestion is make another one, right? For the activity, and let them see the area of this second triangle. And that is also exactly same as this one, right? So from this one, it's not really fixed number, right? The area is actually fixed, right? No matter where this point is, right? So from this way, hopefully the students could figure out, oh, no matter where this C is, the area of this triangle is always same, right? No matter what. The only way it's changing is when you change the distance between these two parallel lines, right? So for that purpose, I prefer to have that point, right, to showing, but like a different color, different style tells my students it's doing something else, right? Okay. So I prepare like that, right? So just changing the position of it, right? Well, then my students will know, right? It really changed the area, but after we fix it, no matter what point we choose here, the area is always same like that, right? So that's what we want, right? And even it goes further, like how it's always same. Then you just need to get the parallelogram, right? So not perpendicular, should be parallel. So this one, and that line. And we need intersection points for that. Okay, then from there, we can show our students this is a parallelogram, right? And of course, when you teach this part, then we already cover what is the area of parallelogram, right? It's the base times heights, the altitude, right? And even you can show like this, right? So even by this way, the quadrilateral area is never changing the same way, right? So if you really want to make this one, if I were you, then I would go from quadrilateral first, right? So no matter what the parallelogram I choose, if I have the same base and same distance for these two parallel lines, I always get the same area for that parallelogram. And one of them is rectangle, right? And one of the postulates in our geometry book says the area of rectangle is base times height, right? So it explains everything. And after that, by this diagonal, this triangle and that triangles are congruent, right? So they get the half of the whole area. So it should be always half of whatever, right? So there is a kind of procedures like try to explain what's going on and why these areas are same and and from there what we can get like that, right? So the goal of this project is why we get the same area, right, for the triangle if we have same base and same distance, right? So from that hands-on activity, we want to explain that, right? So it's not like just tossing out, right, something and just let them do, right? So you should be very careful about when you design it, right? Even you do everything, you might lose some points because of the goal of this project is not matching what you suggest in your diagram, right? So the whole when you make your teaching model, once again, please treat me that you're student, right? And I don't know anything about it. And through this activity, you want to teach something to me, right? So now we know what the goal of this project is. And if it's not matching with that one, then you are not teaching me it right away, right? Then you might lose some points for that, okay? So there are some hints on each project, okay? So I'm going to open them, but I'll do that later, hopefully, okay? After everything is okay. So this is my concern at this moment, right? Because yeah, once again, I know we don't have enough time, right? Making really good the kind of module for this one, right? Yes, but at the same time, if you're just tossing out, yeah, just to make a triangle and to try to find the area, what's going on. It's like this way, right? If you just, without having those properties, then you just got always different areas. That is not, no relation whatsoever that we want to teach through this module, right? Then your module is really wrong. Your design is wrong and your idea is wrong, right? So please thinking about what you want to teach, right? What do you want to explain to our students? Then your design must be that way. So the steps that I put in the course Blackboard for each project, yes, that's the kind of suggestion, but I'm not saying you have to do that way. If you already have your own method, okay, to teach that kind of content, it's okay, right? But if you just do what it says and just saying, yeah, I did it what you said, so right. But once again, this is, I think, is a good example, right? It says make A B, and it has a line and choose a free point, but you just kind of misinterpret the meaning of it. And okay, to get the parallel line, I need a point, so choose point and make a parallel line. Let me use that point to make this triangle, right? It's convenient, but it's not matching what we want to teach, right? You know what I mean, right? So just to be careful when you make your teaching model, right? I'm not asking too much information or too much developed, right? Really nice looking ones. No, but at the same time, it must do what it's supposed to do, right? We are not kind of diagram competition. No, it's not, right? It should work for that purpose of that project, right? So please thinking about that. And if you're not so sure about it, please let me know, right? Please ask me because I think it's clear, but right? Who knows? I mean, so you whenever you want to make sure, please let me know, right? So then I'll answering, and by that way I know what parts needs more explanation and like that, right? So please guide me, okay? That's so. This is just my big concern right now, right? Don't just to do it, right? But thinking about how to deliver that material to your students, right? You can explain everything by yourself, but now, right, using technology means without you, without instructor, students could learn something from using this technology, right? That's the power of using technology. So we wanna train ourselves like that way, right? So when you make your teaching model, you have to think a little more, right? Not just easy drawing, and it's not, right? It's not going to work many times, okay? And your plan is really good, but sometimes, yeah, it's not really that much effective. So let's just worry about that one later. But the basic one should work for that purpose, right? Work for that goal, right? So just be careful about doing that part. So from now on, whenever we meet, I'm gonna just explain what we want to cover, right, in each project. Okay, so that's why my plan today. But yeah, it looks like some of you cannot log in, right? Either. So oh, even the last moment you cannot submit. Okay. Okay. So no, but I think submitting homework is through email, right? So email is working, right? The only problem is Blackboard, not the email server. So yeah, uh, I don't think yeah it should be a problem, right? Email is working. I think I sent that emergency email right now. Okay, so yeah, so uh, okay, I need more material to explain it, right? For each, but I don't have any information right now. So please just thinking about it, and please make your own kind of not making entire one, but like having a plan, right? Okay, for this project, yeah, I want to do this way, that way. Sketch a little bit, right? And just thinking about whether it's going to work or not, right? Like you have to change your role, right? Not as an instructor or producer, right? But as a student, right? Just face on that one, right? And there is no one explain to you. The text part will explain to you, right? And that it should guide you, right? The students, like okay, move around that point, right? Dragging that point C and find out what happens, right? Okay, not just what happens, right? But what happens to the area triangle ABC or quadrilateral ABCD or something like that. We have to pinpoint, right? So through this guidance from this text part, students should know okay, what they are supposed to do and what they are looking for, right? So in that project that I put in course Blackboard, it's not kind of detailed because I want you guys to make practice making your own teaching model, right? So I don't want to kind of fix just one way, right? So I just give kind of rough and basic kind of ideas about it, but after that, it's totally you. So that's kind of my original plan, right? So you should have enough time and making your own kind of a design, right? So, but we don't have time for this semester. So I just kind of cut down all the requirements, but still, right? You just don't just do it and without any connections with the goal of the project. It's not, then that is it's just kind of wasting your time, right? So please thinking about that way. I want more discuss about this more, right? So hopefully all of us kind of figure out what's going on, right? And hopefully it's okay tomorrow, right? So I'm gonna contact IT office and please you guys to do, right? Because and if there is something that we could do, right, then I'm gonna let you know, right? But or they could do in their server, right? And by just click something, then everybody is okay, something like that. But who knows, right? So if you find something, let me know, right? It really makes me annoying. Okay, so but the two main things today is like that, right? To kind of narrow down your size of grid lines, right? So your movements of the points looks like more smoother for our students. And another thing is for your project, no matter what project is, when you make your diagram, you should be very careful, right? Okay. So in this case, it's okay, right? But if you use triangle like this, then whenever your student is moving around, you cannot guide them right in the right way. Okay? So just be careful for those kind of steps. Okay. Okay. I'm sorry for what happens tonight, but hopefully we can see it tomorrow. Okay. I'll send the email after I get the solution about it. Okay. Okay. Thank you and see you tomorrow.